Hey guys, let's talk about weak acids because that's what we're going to be dealing with today. Is weak acid and acid ionization constants, weak bases and base ionization constants, relationship between the ionization constants of acids and their conjugate bases, buffer solutions, and then we'll talk about experiment 2, which is buffers. Okay, so the first thing we're going to talk about is a weak acid. So a weak acid is defined as any acid that is not a strong acid. When we have our HA, our weak acid, and it's in solution, HA aqueous becomes H plus and A minus, just as we would expect, but it's not complete. Okay, so we have a Ka that's given for that, which has H plus times A minus over HA. The value of pH is related to the value of K. So the more the reaction favors making H3O plus, the lower the pH will be, and the higher the pOH. So larger K values are stronger acids. Okay, so if that numerical value is larger, that's a stronger acid. In order for that to happen, the following conditions either must exist or help. So if you have a weak bond between H and A, then that's helpful. HF does not have a weak bond. It has a very strong bond, and that's why it's a weak acid. It needs to be a more stable A minus ion. So if A minus is more stable than HA, then it's a better acid. It comes apart more. The HA bond must be polar, and the more polar, the better. All right. So if that bond is really, really polar, then those electrons are spending more of their time with that anion anyway, and so it's fairly easy to lose that H plus. It's a big deal, right? So that's what's going to determine whether it's a stronger acid than others. All right, so those are our considering factors. I am not going to ask you to look at something and tell me whether it's a better acid or not without K values. Now, if it's a bigger number, that I expect you to be able to deal with. Numbers that we can do. Okay. So, note for the test. If an acid or base is listed in the strong acids bases list on page 7 of the exam handouts, then it is strong. If it is not listed there, it is weak. There are tables on page 10 for weak acids, weak bases, diprotic and triprotic acids. If you need a value for the K for a weak acid or base, they may be there and not on the test itself. Okay, so if it's in those handouts, I may not actually give it to you on the test. But if just because it doesn't appear in one of those tables as a weak does not mean it's not weak. If it's not in the strong, that means it's weak. Okay? So questions about any of that? So that's our definition for a weak acid. Now, the next thing that we're going to have to do is start doing some math with that. So I'm going to close this out, all of a minute that we did, and we're going to go to the next video. All right, guys. I will talk to you soon. Bye.